Alright, so we're firstly going to do a quick recap on what we did in the previous lesson. Um, so if we just take a look at that quickly, we introduced the concept of calculating concentration. So concentration is not too much of a big deal right now. We'll talk about this again in the next section. But just for now, you need to be able to know these two equations that we looked over and just the SI units that we calculate concentration in. So we did a few examples with this, but what was more important about this was this concept of an empirical formula. So we went through these steps here that's highlighted in purple, and these are your basic steps that you will always follow if the question asks you to find your empirical formula. We're going to just do one more example, well, two more examples today, just to make sure you understand this idea. But yeah, these steps, you need to understand them, you need to apply them. So again, we have examples that we did previously. We said that there's two ways they could test you on this. The first is they can give you your elements as a percentage, and if they do that, you need to convert those percentage values simply to a mass value. And the other thing is they could give you the mass directly, and then you can just use your mass to move on to step one. All right, so we did do, I think, 4 examples on that. So today we're just going to recap quickly these steps again. And we're going to do a little bit more of a trickier example today. Right, so the first thing is when you get your question and they ask you to calculate your empirical formula, you need to check, is it in mass, is it in grams? If it's given to you as a percentage, you're just going to simply convert that percentage value to grams, right? And the other thing is they could give it to you in mass. Okay, so the basic idea here is you always want to have your values in a mass value. Once you have it in your mass, step 1, you're going to convert that mass to the number of moles. So in this step, you're obviously using this equation here. The mass here is what you're getting from the question, and this is your molar mass, what you're getting from your periodic table. Okay, we all know how to calculate molar mass by now. Once you convert it to your number of moles, remember, we'll have a table and we'll have certain values for the number of moles here. The next thing you're going to do is step 2, you're going to be finding your simplest ratio. And how you do that is you look for the smallest number of mole value in your previous step. So if we went to the table, sorry about this. So if you went to your table and you had, just for an example, you had like 3 mole, 2 mole, and 2.5 moles. In your next step, step 2 here, what you're going to do is you're going to select which is the smallest number of moles. Obviously, we can see 2 moles here. So you're going to take 2 moles and you're going to divide by each value, right? So that's what you're doing here. You're dividing by the smallest mole value. Step 3, you're going to obviously get answers from that, but you need to round off those answers to your nearest whole number, right? And then once you do that, you basically have your empirical formula. Today we're going to talk about this, but we're also going to talk about this rounding off. There's a little bit of tricky values that you can get, which makes the rounding off a bit not difficult, but you need to be careful about how you're rounding off. So we're going to look at 2 of those examples today. And then just before we actually start that, I just want to make mention of something here. So this is just on the point of rounding off, right? So wherever you made notes on this, you can go to your rounding off, which is step 3, and you can make these notes. So we know that if we want to round off to a whole number, if you have, let's say, 1,98 moles, and you need to round this off. So you want to round off to your nearest whole number. We can easily tell that this number is going to be rounded off to 2 moles, right? Because we've got 9. 9 is closest to the next highest number, which is 2. So this is easily converted to 2 moles, right? If you have something like 1, let's just use 5.10 moles, and you need to round this off again. Easily, we can tell that because we've got 1 here, it should be rounded down, right? So it should be rounded down to 5 moles. So your answer here should be 5 moles. Let's just look at one more. If you've got 3.82 or 88 moles, and you need to round this off, this will be rounded off to 4. Okay, because again, 8 is closer to the higher number. But what if you have a number like 2,50 moles? What do we do here? Is 5 closest to 3, or do we round down to 2? So this is a bit of a tricky one, just because with a 5, we don't really know. It's not as accurate, right? So we don't round off the way we would in maths, where if we have 5, in maths we would say, let's move to 3. In the chemistry part, we want to be as accurate as possible. So what we do here is, if you end up with a number that is 0.5, and this is an important note. So if you end up with a number with a 0.5, what you're going to do is you're going to take that number of mole and you're going to multiply it by some value such that you get a nice whole number here. So start off with the 1. If we're multiplying this by 1, it's not going to make a difference because I'm going to end up with 2.5. So that's pointless. Let's move up to 2. If I multiply 2.5 by 2, right? 2.5 by 2, I'm going to get 5 moles. That's a nice number. So what I would do to this is I would multiply everything else by 2. So the idea here is we're not going to guess, let's round this off to 3. We're going to multiply it by a nice number so that we get a nice whole number here, right? And we'll do an example where you see this, but again, if you're multiplying one of the reactants by 2, you have to multiply everything else by 2. So that's just a note that you need to make a note of, because if you ever get 0.5, always multiply it by 2. Multiply everything by 2. The other one is if you have a number like 3.33 moles. This number again, do we round down to 3? Do we round up to 4? We don't really know, so we're going to do the same thing. We're going to multiply this number by another number so that we get a nice whole number here. So let's see what we can do. If I multiply this by 1, I'm going to get 3.33, which is pointless. So let's take that out. If I multiply it by 2, I think I just mistakenly unshared. I'm just going to quickly share again. Okay, you guys can see it again. Alright, so if I multiply this by 2, let's see what we get. 3.33 times 2. I'm going to get an answer of 6.66 moles. Now this number as well, it's not a very nice number, right? Because we can't really tell if I should round up to 7 or I should round down to 5. So let's try another number like 3. If I multiply 3.33 by 3, I will get a number of 9.99. Oh yeah, 9.99. Now this number is clear, right? We can clearly see that this is very close to 10, so we can round this off to 10 moles. So we will multiply everything by 3. So I hope you see the point here. Whenever you have these numbers where you're not really sure if you should round up or you should round down, what you're going to do in that case is you're going to multiply it by some value so that you get a nice whole number, right? So just keep that in mind. If you need to take note of these two, make a note for yourself. If you ever have a number which is 0.5 or 0.3, take note of this. Alright, so based on that, we're going to go ahead and do one of these examples today. And you need to basically be able to apply the steps now. So your goal should be, you don't want to keep flipping back to your notes and looking at how you do this. You want to start doing it without looking at any notes, doing it from your head. Okay, so we're going to try and do example number 1 today. The question here says that we've got the action of bacteria on meat and fish produces a stinking compound called cadaverine, right? It's a type of cheese. The compound has a composition and they're giving you all the values. So they're giving you it in percentage, take note. So they're giving you 58.77% of carbon, 13.81% of hydrogen, and 27.42% of nitrogen, right? So you've got carbon, hydrogen, and nitrogen. Okay, so I'm gonna just zoom out so that you can see the steps in case you need to. But I'm going to give you guys some time to try this question and then we'll do the answer together. If anything is unclear, if you forgot anything or you need me to re-explain any step, let me know in the chat and I'll be able to do that for you. Alright, so I think it's sufficient time now that we can actually do the answer. If you haven't done it, then just follow from where you stopped. So I'm just going to quickly move this table here so we can use it. Alright, so the first step, what we are doing here is we are setting up our work. So we're going to write this in a table format. Firstly, writing down the symbols they gave us in order. So we've got carbon, hydrogen, and nitrogen. So I'm just going to quickly rule a line here. And then we know that they're giving us, so they're giving us carbon, which is 58.77%, hydrogen is 13.81%, and nitrogen is 27.42%. So the first step is we need to convert these percentage values into mass values. So we've got it in percentage here, we need to convert into mass, and our mass needs to be in grams. So we need to write a little note here, which I mentioned to you guys in the first time we did this. You need to assume that you have 100 grams of mass. So this just tells the person who's marking, this is why you can simply take these values and you can convert it to grams. It's because you are assuming that you've got 100 grams of mass. So what we're going to have now is 58.77 grams. 13.81 grams and 27.42 grams. Okay, so everything is simple now. We've just set up our work. We have everything in grams. So the next step, step number 2, what we're going to do is, well, rather step number 1 here, is we're going to convert the mass values to the number of moles. Okay, so we're going to tell them we're using this equation here. N is equal to the mass over the molar mass. And if we write that out, let's do carbon first. So here we've got 58.77 all over. If we look for carbon on our periodic table, carbon is 12. So we've got 12 here. And if you calculate this value, you should be getting 4.8975 moles. Okay, you can keep about 3 decimal places here. It's recommended that you actually keep about 3 here. If we look at hydrogen, we've got 13.81 all over. Hydrogen in our periodic table has a molar mass of 1. So this is simply going to be 13.81 moles. And lastly, nitrogen, we've got 27.42 all over, again to our periodic table. Nitrogen is 14. And if you put this in a calculator, you should get a value of 1,9571. I just want to check this value again. So you should be having 1.9586 actually. Okay, so please check your work. At this point, you should actually have all these values correct, because up until here, we've just been doing the same thing over and over. Now we're just using the formula, going to the periodic table. So if you have anything wrong at this point, then you should make a note for yourself and you should check what's going wrong, right? Because we haven't been doing any multiplying or anything yet, any rounding off. So up till here, your value should be the same as mine. Just going to make this table a bit bigger. So now that we have all our values in our moles, what we're going to do in our next step, our steps tells us we need to get the simplest ratio by dividing by the smallest number of moles. So we're going to look through these three values and we're going to find which is the smallest value from here. So we've got 4, 13, and 1. So most definitely our smallest value is nitrogen, right? 1.9. So our next step is we're going to divide by the smallest number of moles. Okay, so we're dividing here by 1,9586. So if we take 4,8975 and we divide by 6, we should get an answer. Same thing here. I'm just writing down all the steps in case you need to see them. Okay, so once you put all of this in your calculator, you should be getting your answers here. I'm just going to do it as well. Okay, so for the first one, you should be getting 2,5 moles. The second one, you should get 7,06 moles. And the last one should be 1 mole. Right, so at this point in this, you should obviously just be dividing by your smallest number of moles, and these should be your answers. So again, at this part, if you got everything right, then good work, because you've been following the steps correctly. We haven't done anything fancy yet, we just divided by the smallest number of moles. Okay, if we go back to our steps, once we've divided by the smallest number of moles, now we come to step 3, where we're going to round off to the nearest whole number. So at this step now, you need to be careful. So let's have a look at our numbers. We've got 2.5, we've got 7.06, and we've got 1. So we need to ask ourselves, rounding off to the nearest whole number, is it going to work? I'm just going to write these numbers on the side here. 2.5, 7,06, and 1 more. We're going to basically be rounding off these values here. Okay, let's start off with 1. 1 is a nice whole number, so that's going to remain as 1. 7.0, that's going to simply be rounded down to 7. So this can just simply go to 7 moles. Now we get to 2.5, and I told you now earlier in the lesson, if you came in late, we went through a specific note early in the lesson, which is for the step of rounding off. If you are ever faced with a number like 0.5 or 0.3, you can't round off those numbers directly. Okay, because you wouldn't know whether to round up or round down. So how we get away with the step is we multiply it by a number such that we get a nice whole number. What do I mean? 2.5, if I take 2.5 and I multiply it by 2, I'm going to get 5 moles. And 5 is a nice number, so I'll stick with that. But because I multiplied the one number by 2, I need to multiply everything by 2. Right? So here I'll end up with 7.06 times 2, and that's going to give me about 14,12, and here I'll get to 2. So now you can round off these numbers simply to 5, 14, and 2. Okay, I'm going to go through these steps one more time just because I can understand that it's a bit different to what we've been doing, but let's just go through the steps again so we refresh where we are at. So we had the question, we are simply finding empirical formula, what we did in the last lesson. We were given all the numbers in percentage. So we wrote them down as a percentage and then we converted it to a mass, right? Once we had our values in our mass, we're using this formula to convert to number of moles. So we've got 4.8, 9, 13.8, and 1.9. When we're done finding the number of moles, the next step says we need to divide by the smallest number of moles. We look through the three numbers and we find which is the smallest number. 1.9 is the smallest number, so we divide throughout by that number. Then we end up with numbers like 2.5, 7.0, and 1. Now, you may be tempted to say, well, we're simply going to round off. But when we look at 2.5, do we round this off to 2 or do we round it off to 3? We are very uncertain about it. So whenever you have a number that is 0.5, we are going to multiply that number by 2. Because if I multiply 2.5 by 2, I get a nice number like 5. But if I multiply one number by 2, I need to multiply all by 2. So the next step here, which is kind of like an added step, is you're going to multiply everything by 2. And if you need to put a note about why you're multiplying here, you can make a note is because we have a 0.5 and we want to be certain. So this will apply anytime you have numbers like 0.5 and 0.3. If I find any other examples like those, I will obviously show you so that you are aware of it, because in the exam they will be tempted to give you those types of values, right? Okay, so now we're multiplying everything by 2. So 2.5 times 2, 7,06 times 2, and 1 times 2. So here we have 5 moles. Here we'll have 14,12 mole, and here we'll have 2 moles. Now you're going to go to your step of rounding off. So now you look and you see that it's now become easy to round off because you've got easy numbers. You've got 5, which is already rounded off. You've got 14.1, which is going to be rounded down to 14, and 2 is a nice number. So you have 5, 14, and 2 moles. And that is now your final answer. So now we can write down the empirical formula as, let's see how we had it in order, CHN, and then we simply add in the subscripts, which is 5, 14, and 2. Okay, I'm going to give you guys some time to take down corrections if you need to, but I think I wrote down every single step here. So if you ever need to learn from an example for your exam, this would be the best example because I wrote down every single thing here. Okay, and just make a note for yourself as well. This is a special step. Only when you have numbers like 0.5 and 0.3. Okay, I'm going to give you guys like 2 minutes to take this down and then we'll do another example with this. Alright, so we're going to move on to the next example, and I just want to remind you, especially with this types of questions, if you ever learn something new, even when I'm doing the examples, this is the place where you're not just copying down me doing the answer, but let's say you didn't know that now if you have a 0.5 you need to multiply that number. Make it as a study note for yourself and highlight it if you need to, so that when you come back to this, you actually have learning notes for yourself. Because you can take down notes from my notes, but eventually when you come back to it, you're going to be confused reading it. It's the best to write your own study notes for yourself. So that's just a little tip. Okay, so we're going to look at our next question. This was an exam type question. You can see just for finding the empirical formula, they actually give you 5 whole marks for that. So these questions are really simple. They're nice to score your marks in because it's the same method over and over, right? So as long as you follow the steps we've been doing, and you make sure you don't make any small errors, then you should get 5 out of 5 for this. So we've got 10.2. It says that magnetite consists of 72.41% iron and 27.59% oxygen. They want you to determine the empirical formula of this compound. Okay, so I'm going to give you guys some time to try it on your own, and then when you're done, we will look at the answers together. I'm going to also paste the periodic table down here in case you need to use it. Right, so I'm going to give you some time to try it on your own, and then we will look at the answer. Try your best to do this without looking at any notes. Think of it as a practice question for an exam. Okay, sorry about that, guys. That was my connection. I sent the question in the group as well, just so you can start with it, but I'm going to share my screen now. Okay, so hopefully you can see everything now. If you can't hear me, please let me know in the chat. But yeah, go ahead and start this question, and then we'll mark it in about 10 minutes. Okay, so I think we're going to start answering it just because I just want to have time to also start the next topic for today. Okay, so again, this is a typical exam type question, so let's see where they actually award marks. I'll explain where they're giving you the 5 marks. So let's start. So the first thing is we are given our compounds in percentages. Just before I write anything, I'm just going to draw a table. Okay, so we're only given 2 elements here. We're given iron, which is Fe, and we're given oxygen, which is O. Okay, so we're given it as percentages. We're given 72.41% and 27.59%. So the first thing we need to do is we need to convert that to grams. As I said, we always need to make this note anytime we're given it in percentage. You need to say you are assuming 100 grams of your sample. Okay, this allows us to say 72.41 grams and 27.59 grams. So now that we have everything in mass, we're going to take that mass and we're going to convert it to number of moles using this equation. So we've got, for iron, we've got 72.41 all over. If we go to our periodic table, where is iron? Iron is 56. So if we calculate the number of moles here, we should have 72.41 divided by 56, which gives us 1.29. Alright, and then if we look at oxygen, you've got 27.59, and if we look at oxygen on the periodic table, that is 16, which gives us an answer of 1.72. Okay, so again, up until this point, we're not doing anything new, nothing fancy. We're just simply substituting the values to find the number of moles. You should be very, very comfortable with using this equation. Now, what is our next step? Again, you should be able to do this. You should be able to tell me the next step without looking at your notes. The next step is we're going to obviously look for the smallest number here. Alright, so between 1.2 and 1.7, which number is smaller? Obviously going to be 1.29. So we're going to take every value and we're going to divide it by 1.29. So this means we're going to have this, and we're going to have 1.72 over 1.29. And we're going to get a value here. This is going to be 1 mole. And if we take 1.72 and divide by 1.29, we get an answer of 1.3 recurring. Okay, moles. Now we are going to decide if we can round off this number or we have to multiply the number. So here is where you have to make a decision. Do you round off or do you need to multiply? How would you make this decision? You're going to multiply only if you have 2 cases. You have a 0.5 somewhere or you have a 0.3 somewhere. It should apply also if you have a 0.7, right? But I will look for examples like this just so you are aware of it. Okay, but the safe one is if you have 0.3 and 0.5. In this case, you can see you've got a 1.3, which means you need to multiply this number. How do we decide what to multiply by? I'm going to write it on the side here. So I've got 1.3 and I need to multiply it by something. Let's start from 1. If I multiply by 1, I'm going to get 1.3, which is pointless, so that's not going to work. If I multiply by 2, I'm going to get an answer of 2.6. Now 2.6, it's not a very clear number. It doesn't tell me if I should round off to 3 or I should round down to 2. So let's increase it. Let's go to 3. if I take 1.3 and I multiply by 3, I get 3.9. And 3.9 is a much more clear number. It's telling me I need to round up to 4. So we're going to decide to multiply everything by 3. So I'm going to get 1 times 3 here, which is going to give me 3 moles. And I'm going to get 1.33 times 3, which is going to give me 3,9 moles. So again, special step here. Next step is our case of rounding off now. So here you've got a nice whole number of 3, and 3.9 is simply going to be rounded off to 4. And from this you can write down your empirical formula. Right, what is it going to be? You've got 2 elements, F, E, and O, and you've got 3 and 4. So that's going to be your answer. I hope you guys understand this. Oh, sorry guys, I stopped sharing my screen. I'm going to share it now. I don't know how long I stopped sharing it for, so I'm just going to quickly walk you through the steps. So we obviously looked, I'm going to go from here. We had our smallest number we identified as 1.29. So we took the 1.29 and we divided it by the other numbers. We ended up with 1 mole here, and we got 1.33 moles. Here we had to make a decision, do we round off this number or do we multiply it? You only multiply if you have a number which is 0.5, like a number which is 0.5 and 0.3. In this case, you've got a number that is 0.3, so it's a special case. So we're going to multiply it by 3, and you get 3 and you get 3.9. Now you can round off these numbers easily to 3 and 4, and then you can write down your empirical formula. If you need me to re-explain any step, please let me know. I'm going to give you guys like a minute to take down any corrections. Sorry about that, I mistakenly pressed the button without realizing. Okay, so moving on, that's going to be our last example for empirical formula. I will try to find more of these so you can just practice it. But the next thing is now, remember when I introduced empirical formula to you, I also introduced something called the molecular formula. So we're going to now talk about how do we actually calculate the molecular formula. So if we were to define what molecular formula is, it is simply the actual ratio. It is the actual ratio of an atom of the atoms in the molecular mass. The molecular formula can be calculated from the empirical formula and the relative molecular mass. So we'll talk about all of this, but basically, if you want to calculate your molecular formula, you need your empirical formula. So you need the empirical formula if you want to calculate molecular formula. We'll do this by way of example. It's a lot easier than empirical formula. There's only like 2 steps you need to know here, so it's a bit simpler. So how do we calculate the molecular formula? Okay, so I think I'm going to give you the steps first before we actually do the example, and then after the steps you'll be able to follow. So the first thing to take note of is that when you're calculating molecular formula, in the question, they will give you the empirical formula. If they don't give you the empirical formula, you would have to find it. So how they could test this is they'll give you a question, and question 1 will be find the empirical formula, and the next question will be find the molecular formula. Either way, you must always have the empirical formula to start off with. So once you have your empirical formula, they might also give you, so they'll give you the molecular mass. So they'll give you molecular mass. Okay, so we will refer to this mass as the given molecular mass later on. So once you have these two things, you can move on to step number 2, which is you are simply going to find your molar mass. What is molar mass? This comes from our periodic table. But this is now a specific molar mass. We will call it the empirical molar mass. Okay, so it's coming from the periodic table. So when you are finding empirical molar mass, you are going to be using the empirical formula. That is why you need the empirical formula here. So I'm going to highlight that in one color. When you're finding your empirical molar mass, you're using the empirical formula. Okay, so you found your empirical molar mass and you've got your given molecular mass. So your third step is where you're simply going to find the ratio between those two. And that would look something like, when you need to find this ratio, it's going to be equal to the given molecular mass in the question. You're going to take that given molecular mass, and the hint here is it's usually the larger value. So if you ever forget, the hint is it's always going to be the larger value. You take your given molecular mass and you divide it by your empirical molar mass that you found. Right, so you divide both these values, you should get a number from here. Once you find this number, that is going to be your ratio. So your fourth step is you're going to take your empirical formula, which you have given from the question. You're going to take that empirical formula and you're going to multiply it by the number. I know I unshared, I'm going to share quickly again. Okay, I hopefully wouldn't do that again. I just hit that bar so I wouldn't mistakenly press it. Okay, so you're taking your empirical formula and you're multiplying it by that number that you found. So these are the basic steps of how you would calculate your molecular formula, and we'll do a quick example to illustrate it. Okay, so while you're taking this down, I'm just going to write down the question. Okay, so we have about 10 minutes. We should be able to easily get through this example. Just going to give you guys like 2 more minutes to take down all of the stuff, and if you're done taking it down, you can actually start doing the example by using the steps. This finding the molecular mass, as I said, molecular formula, sorry, is much easier than finding the empirical formula. So I'll give you 2 minutes to attempt and take down everything, and then we will look at how to calculate it. Okay, I'm going to start answering it just so we have enough time to complete the correction. But just before we finish, tomorrow we're going to complete this section, and we're going to also start talking about something called the limiting reagent, which is a very important section. So, alright, so firstly we're given the empirical formula, just going to underline that, CH2, and we're given the molecular mass, 56 grams per mole. So we obviously have point 1 checked. Point 2 is telling us we need to find the empirical molar mass. So we need to get the empirical molar mass. What is that? That means you're going to find the molar mass of CH2. Why CH2? Because CH2 is the empirical formula. Okay, so you go to your periodic table and you're going to find these values. Let me just quickly bring this down. Okay, so if we look for carbon, carbon is 12 plus 2 times hydrogen is 1. This is going to give us 14 grams per mole. So this is our empirical molar mass that we found based on the empirical formula that they gave us, CH2. So this is checked. Step 3, I'm just going to write down the step numbers here. Step 3 is going to find out the ratio. So the ratio, which is equal to the given molar mass all over the empirical molar mass that we just found. Okay, let's substitute the values. The given molar mass, where is that? This is our given molar mass in the question. So it is 56 all over. And then we're looking for the empirical molar mass. We calculated that here. So that is a value of 14. If you divide these, you get a nice number of 4. So that becomes our number. It becomes our ratio. So the next step, you take that number and you multiply it by the empirical formula. So step 4, the empirical formula is CH2. We take that and we multiply by 4. And if we do that, now this is important, I'm not writing it down in the steps, but what does this mean to take the empirical formula and multiply by a number? It does not mean, let me just write it here in big, it doesn't mean you put a 4 in front of CH2. This is not what it means. It means you take the subscripts and you multiply by 4. So 4 multiplied by each subscript. The subscript here is 1. So you're going to get C4. So you're going to get C4 here and you're going to get H8. Why 8? Because you've got 2 times 4. So let's just make a quick note of that here. This means you multiply the subscripts by the number. Okay, just take note of that. So here we would get C4 and H8 because 4 times the small 2. Okay, so see, that is basically it. It's not a very complicated series of steps compared to empirical formula. It's just these 3 steps that you need to understand. Okay, so I was going to do more examples with you for molecular formula. I'm just seeing. Okay, I think we'll leave it for tomorrow just because I don't want to rush you with this. Make sure today, we didn't do a lot of work today, we just simply looked at the empirical formula again. Make sure you understand those steps early on. You learn the steps, and then today we also looked at how you find your molecular formula. So go through these steps here. These are new steps we learned. Make sure you understand these steps. Familiarize yourself with the question, the example that we did. In the question, what information do you need to be given and what do you need to find? Okay, and then tomorrow I'm just going to quickly show you what we're going to be doing. So we're going to be talking about something called a limiting reagent. What is this? Basically, when you have a chemical formula, you know we always start off with reactants to get products. So I may have something like oxygen plus nitrogen to give me nitrogen dioxide, right? This is not a balanced chemical equation. But if I'm reacting with oxygen and nitrogen, usually I'm not going to use all the substance that I have. So if you think about a lab and you think about your test tubes, if I've got this much oxygen and I've got this much nitrogen, I'm not going to end up using all of the amount that is in the test tube. I may use all the nitrogen, but I may only use this much oxygen. So I might have some left over. Limiting reagent refers to the substance where we use all up. So you need to use everything up in order to form the product. Okay, if you've got excess, like oxygen here, you can see that the pink highlighted part represents the excess amount. That is not a limiting reagent. So that in a nutshell kind of describes what a limiting reagent is. And it's very important because in order for you to calculate how much of product we are producing, you have to be able to do your calculations based on the limiting reagent. You can see in the notes, which we'll go through tomorrow as well, but it's important because it's going to determine the amount of product that's formed. And in chemistry, it's very important to be able to find out how much of product am I actually getting from the reactants that I'm using. Okay, so that in a nutshell is what we will do tomorrow. It's very calculation based. So just make sure you understand the work we did prior to all of this. And if you don't have any questions on what we did today, or if you need to take down anything else, then that is it for today. I'll see you guys tomorrow.